guys, today we're going to talk about multiplicative law of probability. What's that? If A and B are any two events defined in a sample space, then let's say this is A, this is B, and they're having something in common, which is known as A intersection B. And then we're going to say A intersection B. Like, what is that? Let's say A intersection B is equal to probability of A in probability of B over A, in which probability of A is not equal to 0 because that will just give whole as 0. Or we can even write as exchanging B with A and A with B, like probability of B, probability of A over B, provided probability of B is not equal to 0. Okay. So as we know, probability of A over B or probability of B over A is formula. What's that? Conditional probability of B given that A. We're gonna talk about that one now. You just like probability of B over A is equal to probability of A intersection B over A probability of A. Now we have this one here. And this is a formula of conditional probability of B given that A. So we're going to multiply both sides of this one with probability of A here. Okay. So we're going to say probability of A with this one and on this one on this side too. Okay. So when we're going to multiply this side with probability of A and this one with this probability of A, and then probability of A will be cancelled with probability of A, and we will get our desired formula here. It's like this one. Okay. That's how we do. So this is just as simple as we are just gonna say that A and B are two sets and they are having something in common. We're gonna say A intersection B, in which like probability of A, and whenever there is intersection, we're gonna just divide them off like probability of B over A. And then as we know, we can exchange their like A with B and B or with A, and for here probability of it can never be 0, and same for here probability of B can never be 0. And we already know the formula of probability of B over A, which is like this one, which is probability of A intersection B over probability of A. Like probability of A will be same, but here the probability will be A intersection B. Then we're gonna multiply both of them with probability of A, in which the probability of A will be cancelled out, and we will just get this one as this one. Like these are just like 2 or 3 steps formula. So how are we gonna prove it off like here? Like we have to prove this one probability of A with probability of B over A. Okay, or even we can prove probability of B or probability of A over B. Like both are same as we know. So we're gonna just prove it off here. We're gonna say if S3 presents sample space, let M1 number of sample points A. Let's say M1 is like A, M2 is like B, and M3 is A intersection B. Okay, as we know. So probability of A will be like M1 over N, probability of B will be M2 over N, and probability of A intersection B will be M3 over N, as we know. Then, if we're gonna talk about probability of B intersection A, we're gonna say M3 over Mn, M3 over N, because B is like M2 over N, okay? And A is like M1 over N, M1 over N, like we know. So how are we gonna just change it off here? Like as we know, probability of A intersection B is equal to M3 over N. So as we know, probability of B intersection A is also like that, like M3 over N. Like both are same, no issue. So we can just gonna multiply and divide it with M2. So why are we gonna do this? Because M3 over N or like M2 over N, we can get probability of B. And for M3 over M2, we can get what? Nothing there. But we're gonna just multiply and divide both of them with n2 because we just need something which is not gonna be there, but we need them. So as we know, probability of intersection B is equal to m3 over n, probability of B intersection A is equal to m3 over n. Just so we have nothing more option there, so we're gonna just multiply them off with m2. Okay, just use some mind there. So m2 over n will be probability of B, and then we will be left with m3 over m2, but we're going to multiply both of them with n now. M3 over n will be probability of A, okay, and m2 over n will be probability of B. Okay, so that's how you do, that's how you get it off, like probability, like this will be m3 over n, which means probability of a intersection b, and this will be like m2 over n, which is like b. This one is like a, so we will get this one. But if you're gonna multiply them with something else, like m1 here or like that, so we can also get a intersection b. Okay,